Hello, ladies and gentlemen. My name is Mr. Bryce, and I'm with Susquehanna Valley High School in Conklin, New York. Our zip code is 13748 if you want to contact me. Today, we're going to be talking about solving systems of equations by substitution. For you teachers out there, standard A-REI.5 is by elimination, and A-REI.6 is solving systems exactly. Someone used that for elimination and substitution, and also graphically. So we are on page 131 of my book. So make sure that you're on it. It actually isn't physically my book. I didn't make these worksheets, but I put them together, a compilation of a whole bunch of different workbooks. Anyway, let's get on to solving systems algebraically by substitution. There are a variety of ways that we solve systems of equations, okay? Now, we can solve them graphically, as we just finished, but substitution is very powerful. I am not in the room with you right now, okay? This video is substituting me being with you to instruct. I am at a meeting right now down the hall, and there is a substitute teacher in the room. Wave your hand, Mr. Substitute or Mrs. Substitute. Thank you very much. That is the substitution. They are taking my place. So that's the same thing we talk about substitution here. Consider the system given below. Here's the system, and its solution is x equals 4 and y equals 1. Show that the point 4, 1 is the solution to the system. All you have to do is everywhere you see an x, you write a 4, and everywhere you see a y, you write a 1. So through the magic of recording, I did the work there. No need to write it down. There we have it. Because we've been doing this for several days, we understand what substitution means. What substitution means here is everywhere I saw an x, I put a 4. Everywhere I saw a y, I put a 1. Same thing here. I saw a y there, so I put a 1. I saw an x there, so I put a 4. And it checks. Okay, what's the big deal? Well, here's the big deal. Show substituting in the x minus 3 for everywhere that we see y in the first equation, and show that the point 4, 1 is still a system. Okay, so it says take the x minus 3. Why would it say take the x minus 3? Because here it says y is the same as x minus 3. Equals is a very powerful word. Equals means the same. If I give person in seat number 1 y, and I put seat number 2, I give the person x minus 3, I am treating them equally. How do I know I'm treating them equally? Because it says the two are equal to each other. So now it says instead of writing y, I can write x minus 3. I grab the first thing, grab it. 2x plus y equals 9. Is the 2 a y? Absolutely not. So I copy it down. Is the x a y? Absolutely not. So I copy it down. Is the plus a y? No. Is that a y? Ding, 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 ding. Substitute. Instead of writing y, write x minus 3. So I, just for good practice, always put it in parentheses. The equals is not a y, so I write it down. The 9 is not a y, so I write it down. Now notice, I started with 2 variables, and now I have one equation with 1 variable. The number of variables that you have in a system has to be the same as the number of equations in order to solve it. If you have 5 variables, 5 letters, and you only have 3 equations, you cannot solve it. With 5 variables, you need 5 equations. Here, we have 2 variables, x and y, and we can solve it because we have 2 equations. Now, the second one that I've just created through substitution is identical to the first one because substitution means I took equals and replaced them with each other. Now what can I do? I can combine like terms. Okay, 2x plus, there's no distribution here, so it's x minus 3 equals 9. Now I just have, x plus 2x is 3x minus 3 equals 9. And then add 3 to both sides. So I have 3x equals 12. Divide by 3, x equals 4. If you have to hit pause now so you can write all that down. X is 4. So we see here that x is 4. Okay, we got the x part satisfied. Now let's get the y part. Solve the system by finishing the substitution from B. Okay, now we're going to get the y part over here. I'm going to grab that one because it says y equals x minus 3. What was x? X was 4. So y equals 4 minus 3. 4 minus 3 is 1. There is my y part. Bingo. I just solved that by substitution. If you have to rewind and listen to it again, go right ahead. Okay, I'm going to do one more as a model. Okay, I'm modeling this for you. First of all, I look at the two equations. I notice that this one says y is the same as all of that stuff, 2x plus 5. And I notice this one also says y is the same as negative 3x minus 10. So since I have a y by itself with either of them, okay, that means that I can either take and substitute y, and instead of writing y in that equation, I can write 2x plus 5. Okay, first come, first serve. So I'm going to take the 2x plus 5 and write it instead of y. 2x plus 5. Now the next thing was an equal sign, and after that was negative 3, and after that was x, and after that is negative, and then after that is a 10. Okay, well, you're like, Mr. Bryce, that doesn't say negative, it says minus. We know what we feel about those things, okay? So draw the big line, combine like terms. It's a lot easier to move negative 3x's than it is to move positive. So here I have 5x plus 5 equals negative 10. Subtract the 5. 5x equals negative 15. Divide by 5, and x is negative 3. I didn't solve it yet. I have an x, so don't fall into this trap. I have the x. Now, I have to find the y. Grab an equation. Y equals 2. Instead of writing x, it says write negative 3 times negative 3 plus 5. So y equals negative 6 plus 5, y equals negative 1. If you want to, write it as a point. Negative 3 comma negative 1. Now what's extremely important here is to check. We substituted in to the first equation to find, so now I'm going to check using the second equation. Instead of writing y, we're going to write negative 1 equals negative 3. Instead of writing x, we're going to write negative 3 minus 10. I don't know if this works or not. Negative 1 equals negative 3 times negative 3 is positive 9 minus 10. Now, 9 minus 10 is negative 1, so it does check. Negative 1 is the same as negative 1. Now, at this time, I'm going to ask the substitute teacher, please hit pause and instruct the students to do B on their own. And when I say on their own, I mean they can talk to the person next to them, but you're not going to do it. There's my substitution. There's my distribution. There's my combining like terms. There's my solution for x, but not for y. Let's find y. And in red is my solution for y. We can write it as a point as 3 comma negative 2. Remember, if I want to have a solution set, I can write them in braces. If you have to hit pause, make sure you hit pause now because I'm about to erase it. So on the next page, what we have is we have a little bit of puzzle here. Oh, by the way, let me give credit where credit is due. Okay, here on the bottom, Common Core Algebra 1, Unit 5, Systems of Linear Equations and Inequalities, Lesson number 1 from E-Math Instruction, Red Hook, New York. Great job. Thank you very much. That's his worksheet. So here, it's a little bit of a puzzle here. Max and his father are comparing their ages. They know the sum of their ages is 52, and Kirk is 7 years older than 4 times Max's age. Okay, if Max's age is represented by M and Kirk's age is represented by K, write a system of equations that describes the two relationships from the problem. Just write the system. It didn't ask to solve it. Okay, so the first thing I'm going to do is Max and his father comparing their ages. Okay, nice. They know the sum of their ages is 52. Max plus Kirk is 52. Now, some of you good students may want to put those in parentheses because we know sum is add them first, and we have to do that before we do anything else. But there's nothing else done in this. So M plus K would be fine. But I want you to remember that sum also means put them in parentheses. Find that addition problem before doing anything else. And that Kirk, this is another equation. Kirk, I'm going to use a little bit darker color. Kirk is 7 years older. 7 plus 4 times Max's age. Okay, so hopefully you had that well before I did. So there are the two equations. What's nice about this is we can solve it using substitution because K is already all by itself. So solve this system. I'm going to grab that equation and it says M. Okay, M is not K. Then it says plus K. Substitution, instead of writing K, we write 7 plus 4M is 52. Solve it. Go for it. I don't know if any of you are done yet. M is 9. But guess what? We want to know both their ages. If Max is 9, then take an equation. Why don't I take that one? So here we have, sorry that I'm running out of room here, Max plus Kirk is 52. I know Max is 9. Subtract 9 from both sides, so Kirk is, do you have it? 43. So here are two more classic problems. Okay, the first one is a cell phone. The second one is two people walking towards each other. Exercise 4, 2 cell phone plans offering different packages. 2 plans are outlined below. $5 per month, along with a charge of 3 cents per text. So if you never use the phone, you're still charging $5 a month. The other one, no monthly charge, but 10 cents per text. So if you text a lot, Okay. Is there a certain number of texts when the two plans cost the same amount? So let's write an equation for plan A. Plan A, $5 per month. No matter what, that's going to be constant. Constant, $5 per month. So that's what we call the y-intercept. The rate of change, Tom versus Sally versus Mike versus George versus Patricia, is 3 cents. 3 cents per text message. That's where it's different from person to person. Plan B, there is no fixed charge, but the text is 10 cents. So that's where the change is going to be, the rate of change. So there are the two plans. Now it says, determine the answer by setting up a system of equations that model each other. We want to know when they're going to be the same amount. The same is exactly saying they're equal. Those two are equal to each other. So 5 plus 3/100 of a t, when does that equal 10/100 of a t? Well, I'm going to subtract the 3/100 of a t from both sides. And then divide by 7/100. No offense to the author of this worksheet, but they're never going to be the same amount because you can't send part of a text, okay? There is not part of a text. That's a decimal. That's part of a text message. So they're never going to be the same amount. When are they going to be closest? 71 texts, okay? So I'm sure that they had all good intentions. That should have come out to be exactly a whole number. So when are they going to be the same? Never, because you can't set part of a text. And away it goes. Now let's take a look at this one. A man and a woman are 380 feet apart from each other, and they walk in a straight line towards each other. If she's walking at a rate of 6 feet per second and he's walking at a rate of 2 feet per second, when will they meet? Okay, this isn't a Zeno's paradox. They will meet. If she's walking at a rate of 6 feet, so she's going at 6 feet per second, and he's walking at a rate of 2 feet per second. Now, just sit back, relax. You don't have to take any notes. I want you to watch this and observe. So what we have is, remember, distance equals rate times time. The distance is 380 feet. Now, when you're walking towards each other, okay, have you ever been driving down the road? Let me back up a second. So if you're ever driving down the road, down the highway, and you want to pass a car, you look at the speedometer and it's going 55 miles an hour, but the car looks like that you're passing, just creeping slowly back, like 1 or 2 miles an hour. That's relativity. So that's what's happening here. You're moving towards each other very fast. Okay, so here, sorry, that's relativity. You're not moving towards each other very fast, but here, these people, they're moving towards each other faster than what they're actually moving. When you're driving down the road and a car is approaching you and you're approaching them, if you're going 60 miles an hour and they're going 60 miles an hour, it would be the same thing as them going 120 miles an hour towards you if you were standing still. Okay, that's breakneck speed. So you never want to have a head-on collision because it's combining the two. So what I'm doing here is we can combine the rate. So I combine the rate. And then we have 380 feet equals 8t. Divide by 8. Divide by 8. Now, can we have a decimal for time? Of course we can. Because you can have like a half of a second or a quarter of a second, things like that. So it is 47.5 what? Seconds. Okay, you're doing a fantastic job. You've got lots of class time left. It shows me that we still have 21 minutes left to the class period. So you can do the next 2 pages. 133 and 134. Have a great day. If you have any questions, I'll see you tomorrow.